Red line represents the current number of adjacency. There are 5 pairs in total. Only 1 pair of neighbors. But you can try it after class. 5 devices. 6 devices. Or 7 devices. Even more devices. You can see. The number of adjacency will be reduced. You can't see it if you look at it this way. Because of less equipment. If there are many devices, you can see the difference. The following is a matter of priority. You want it to be DR. Change it to 255. When we wait for the configuration, we will say, look down. Finally, this is the OSPF area. Let me just say this. I just told you. OSPF backbone area 0. This is area 1. Area 2. Area 3. If on a device, there are some other external routes introduced. Let's not talk about these. Include these ABRs with these names. No need to talk. Because we are only talking about area 0 now. The meaning of this picture is to let you know. OSPF divides the area. Each region maintains a separate database. And 0 is the backbone area. Other regions must be connected to it. Certainly. You will also learn virtual connections in the future. Also called virtual link. You can make it connect manually. Is equivalent to I make a virtual connection to connect it. But if this way, we'll create a loop. But this thing. In fact, there are not many used in the network. That is, it is absolutely impossible for you to see someone using a virtual connection on the internet. But what we learn, you still have to learn this technique. If you plan, these areas must be separated from area 0. That's a technical problem. Let's make one last point. OSPF overhead. It is called metric in EIGRP. Actually, this is the routing metric. In fact, it can also change the bandwidth in OSPF. It is the bandwidth reference value divided by the bandwidth. Cisco is 8 out of 10. You just know. The greater the bandwidth, the smaller the cost. Therefore, OSPF will choose to take the link with large bandwidth. But what we modify here does not change bandwidth like EIGRP. We just change the cost directly. Because its parameter is based on the bandwidth. So it's more monotonous. It's not like EIGRP. 5 references in EIGRP. You can't calculate a comprehensive value and change it directly. But OSPF only refers to the bandwidth. So this value based on the bandwidth is also unique. So you just change the cost directly. Okay. All of the above is the theory of OSPF. Next we configure. Let's turn the device on. When the device is turned on, let's talk about the scene of today's experiment. This is also the homework for you today. The experimental requirement is configure the address first according to the plan. Then run the OSPF protocol. Then process ID and area number. R2 This does not allow the network command. I just told you. In fact, it can be declared under the process. It can also be declared under the interface. After that, we will make the left interface of R2 become the DR forever. Then we thought, priority can be modified. And the last, the routing cost of 2.2.2.2 we learned on R1 is always 20. This is a bit complicated to say. Then let's take a look. I saw a classmate ask, is DR generally placed on the core layer device? Generally for us. Not a core layer device. The core equipment is selected with the highest performance. But in fact, everyone is not so clear about the network architecture. For core equipment, We run OSPF there. In fact, it is not to set up this kind of OSPF scene. It has other uses. Generally speaking, we will run OSPF between the egress and the lower device. Maybe give it a default. That is, its structure will be different from what we talked about today. But we generally choose higher performance. It's okay. You have to understand the various devices. Where is it used? First of all, you have to learn the multi-region. First take a look at how it is designed for the entire network. Let's configure it a bit. The first thing to do is to change the name first. This is R1. R2 also configure it. We come to the device R1. We readdressed. Interface E00. The address is 12.1.1.1. No shutdown. Then we go to loopback 0. It is 1.1.1.1. This is R1. Then R2. Also the 00 interface. The address of the 00 interface is 12.1.1.2. Go to the loopback port and configure an address. 2.2.2.2. This is the loopback port of R2. OK. Our address is configured. After configuration, ping 12.1.1.2. See if you can connect directly. Is passable. So we now start to configure OSPF. It is very similar to EIGRP. First of all, our routers. Router OSPF. Here is a process ID. By default we wrote OSPF 100 here. When we come in, first configure router ID. The format of router ID is dotted decimal. Then we usually configure it as the address of the loopback port. Router ID 1. 1.1.1. After we finish matching. Further down, we are going to complete the declaration. When we enter the announcement, write process ID to it at the same time. So we're going to start making announcements now. First we declare the direct connection. The purpose of declaring direct connection is to establish a neighbor relationship. Is to establish OSPF relationship. Network 12.1.1.0. It is the same as EIGRP. 0.0.0.255. Excuse me. I forgot to write the area here. Followed by an area 0. This is equivalent to. We declared such a network segment into area 0. Or. Declare the network segment where this interface is located in area 0. It means that this interface will be divided into area 0. This is the first. Article 2 Declaration 1.1.1.1. Then the mask is the same. Wildcard. First understand it as an anti-mask. We're done. After the announcement, I will teach you a simple way to view commands. Show run. Let's look at the configuration now. Then here. There's this vertical bar. Pipe symbol. We won't go into detail about this right now. Remember this set of orders first. Show run vertical bar section OSPF. Just look at the configuration of a module. OSPF configuration on my device. A router ID. 41. That is the loopback port address. And the last internet segment. It's the first one we're talking about. Let's look.